We're going to start bending our algebra brains a little bit and think about absolute value. Now, just remember, before we start here, just remember that absolute value means the distance from zero, okay? So if I said, and we write it like this, we write the number that we're interested in the absolute value of, and we write these big vertical bars around it. And that means the distance of 3 from 0. And so if we put it on a number line like this, and there is 0, and there is 3, and then here we have 1, 2, 3, what this is asking us is how far is the 3 from 0? And it is 1, 2, 3 away from 0. So the absolute value of 3 is 3. But you also might remember that I could also go the same distance of 3 but in the other direction. So I could go down here to -3, and I'm still traveling 3. 1, 2, 3 in the negative direction. So the absolute value of 3 is 3, but this is also exactly the same as saying the absolute value of -3. They're the same. The absolute value of -3 and the absolute value of +3 are both 3, because I can go 3 in this direction or 3 in this direction, and I get two different numbers, but they're the same distance away from 0. Okay? So just a little refresher about what we're talking about here. Now we're actually going to put that absolute value, of course, into an equation. So let's talk about how this is going to work out. Okay? So absolute value just means the distance from 0. So there are two numbers that have the same absolute value, and they are additive inverses or opposites of each other. Okay? And what I mean by additive inverses here is that if you're looking at 4 and or let's say -4 and +4, they are the same distance away. And this is if you're just talking about a number, a single number like we were talking about here, okay? And here we were talking about 3 and -3. Let's say we're talking about the number 4, okay? You're going to have 4 going this way and 4 going this way, and you get to +4 and -4. If you add those two numbers, they're going to give you 0. So -4 plus 4 equals 0. When I say additive inverse, I mean that they are, when you add them up, you get 0. Now this is just for single numbers. Okay, this is the easy stuff. So the absolute value of 4 is +4 or -4, because I can go, okay, I can go, oh, I'm sorry, I wrote this down wrong. What I meant to say here is not this. I meant to say that the absolute value of -4 is also the same thing as the absolute value of +4, and they both equal the number 4, okay? Because I can go 4 in the positive or 4 in the negative. And like I said, this is just dealing with single numbers, okay? So we're going to turn this into more of an algebra thing and deal with it in equations. So what if you have something like absolute value of x equals 6? Okay, then x equals 6 or x equals -6, because if I plugged in a 6 right here, imagine if I just plugged in a 6 right here, because the absolute value of 6 is 6. So that's this one. So that one makes sense. The absolute value of 6 is 6. But what if I plugged in a -6 right there? Well, it'll still work, because -6 is still 6 digits away from 0. So the absolute value of -6 is also 6. So I have two possible solutions. I could plug in a 6 right here or a -6, and I'm going to get a correct answer. So both 6 and -6 would work for x. So this is what we're going to start thinking about with equations, okay? We have two possible scenarios that came out of it. Now, because we were just looking at the x and the absolute value, it turns out that these are kind of opposites of each other, 6 and -6. It's not always going to be that way, so I want you to realize that when the equation gets more complicated, they're not always going to be additive inverses, and we're going to look at some of these examples right now. Okay, it depends on what you're actually taking the absolute value of. If the absolute value is just around the x like that, then you will get opposites. You will get a positive and a negative of the same number. Okay, but if you have other stuff in the absolute value in here, like if I had I don't know, x plus 4, and that was the absolute value, then this is going to start changing. So let's look at some more information here before we get started. Technique for solving these. Okay, this is a little bit different, so I'm going to highlight this. This is a little bit different than what we've been doing. Instead of isolating the variable, we talk about isolate the variable using inverse operations. We've been doing that in equations. Here we're actually going to be isolating the whole absolute value. Okay, this is a little bit different. We're not just isolating the variable. Our first goal here is to isolate the actual absolute value sign. Okay, not just the variable. Okay, not just the variable, and get that on one side of the equal sign. Okay, and then we're going to, this is also new, then we're going to split the equation into two cases. And these will be kind of the positive and negative version of each other, which I'm going to start calling opposites. Okay, they're really called opposites. Because it doesn't have to be positive and negative. It might be backwards in what you would think. Note, even though you can think of it as one positive and one negative because we're doing absolute value, note that what if x equals a negative 4? Well then, what would I get if I get a negative x? Would be a negative 4, right? Which would just be the positive 4. So the positive x may actually be a negative number. And I actually wrote that down here. The positive x can be negative. It can be a negative number. Let me clarify that. The positive x can be a negative number. So in that case, negative x just means the opposite of x. Okay? So just like I said up there, if I had x equals, I don't know, negative 7, then negative x equals positive 7. See the difference? They're just opposites of each other. So it is, of course, time for examples. So let's look at this one. The absolute value of 6m equals 42. Okay, so the absolute value is already solved for. Notice this is what we're trying to solve for here. We're trying to isolate the whole absolute value, and then we split it into two cases. Okay, so I'm going to use green to split into my two cases, and then I'll use red to show the steps like we usually do. So this is two cases. So what this is saying is that whatever is in here, whatever this value is, it is 42 units away from 0. Okay, whatever this value is, it's 42 away from 0. So that is how we know that we have to split this into two cases. Case number 1 is, and just watch me here, is just the exact same equation without the absolute value. And then case number 2 is the same equation, but it's the negative version, or it is the opposite version. Okay, so notice here that the only difference is I'm taking care of this, because if this 6m equals negative 42 and I had a negative 42 in here, then the absolute value of that negative 42 is still going to give me this 42. So as long as I have, notice what I'm saying here, as long as I have 42 in here or minus 42 in there, I'm still going to get 42 as the answer, this 42 here. Okay, so either one of those scenarios is cool. And so what that tells me is that I have this scenario where 6m equals 42, which is this case, and I have another scenario where 6m equals negative 42, which is this scenario right here. See what I'm saying? So I'm just going through and I'm saying, okay, that equals that, and that equals that, and those are my two solutions. Okay, so let's solve this. Let's solve this. So I want to solve for the m, of course, so nothing is changing. I'm just dividing by this, and I'm getting those cancel, so I'm getting an m equals 7. So there is one of my answers, okay? My box kind of went a little crazy. Okay, and over here I'm going to do the same thing. I'm still dividing by 6 and dividing by 6. And so those cancel, and I'm getting an m equals -7. Okay, so there are my two answers. Okay? Okay. Let's look at this one. The absolute value of k minus 10 equals 3. The absolute value is already solved for. It's isolated by itself. So we can split into two cases, okay? And the first case is just going to be the same problem without the absolute value, and the other one is going to be the negative version of it. Because again, I don't know what k is or what k minus 10 is, but as long as this bit here as long as this is 3 or -3, I'm going to get 3 as the absolute value of that. So here's my case number 1, and here's my case number 2. Okay? That didn't really show up like I wanted it to. Case number 2, case number 1. If you just imagine that k minus 10 equals 3, and k minus 10 equals -3. Okay? So here we go. So now I'm, of course, going to add 10. Okay? Add 10. And here I'm going to get, so those cancel. And so I'm going to get a k equals 13. Okay? And here, of course, I'm going to add 10, and I'm going to add 10. And so those cancel, and I get k equals goodness gracious, +7. K equals +7. So here's an example where, if you notice, these are not additive inverses of each other. I have k equals 13, but I don't have k equals -13. And this is, by the way, this is an equal sign here. I just realized that I did not write it very well. I don't have -13 over here. You know, all the other ones I've had 7 and -7, but here I don't. I don't have 13 and -13. I have 13 and 7. So here's an example of where it's not additive inverses of each other. They're not just the negative versions of each other. So you can't just jump to the conclusion. Notice here that my absolute value is not isolated. I have the absolute value of n, and then I have +1. So I have to deal with this +1 before I do anything else. Okay, so here's the absolute value of n, and then of course those cancel, right? And so I have 2 minus 1 is just 1. Now I can split into my two cases because I have the absolute value isolated by itself. So when I split into the two cases here, I'm going to just have n equals 1, and of course over here I'm going to have n equals -1. Okay, and that I've already got my answers. I don't have to do anything else. N equals 1 and n equals -1. Sorry, I went off the screen there. Okay, so this one was just the same equation without the absolute value sign. This is the negative version of it. And I don't have to do any more steps. I've already got my answers. Okay, more examples. More examples. Okay, so the absolute value of m divided by 5 equals 3. Notice that I don't have an isolated absolute value. It's divided by 5, and that's not part of the absolute value. Okay? I want you to just notice the difference here. Just take a second and notice the difference between what I have and this. Do you see the difference there? In this one, the whole fraction is inside the absolute value, and here just the m is inside the absolute value. Make sense? Okay, so just be careful. So here I need to multiply by 5 and multiply by 5. And of course, this 5 and this 5 are going to cancel, which is why we're doing it. And so I'm getting out of that, I'm getting the absolute value of m equals 15. And now I have the absolute value by itself. So I can split into my two cases. I can say, okay, well, m equals 15 and m equals negative 15. Okay, and I've already got the answers here. I don't have to do anything else to that problem. Okay, so here's the absolute value in this one. Now I've got an entire fraction in the absolute value, so just be careful there. So this is x over 7, absolute value of that whole fraction, and then minus 8. So I'm still going to have to get rid of the minus 8 first because I want just the absolute value by itself. So now I'm going to have x over 7, absolute value, and of course these are going to cancel, and 7 plus 8 equals 15. Okay, so now the absolute value is by itself. Notice that the absolute value is the only thing on the left of the equal sign. So now I can actually split this apart. And I'm kind of running out of room here, so I'm just going to go over to the side. So I'm going to do the first case is just the same thing without the absolute values, and then I have this, and I have the negative version of it. Okay, so now I'm going to multiply by 7, which is my inverse operation right there, and those cancel. So now over here I have x, and I have 15 times 7. Okay, well, 10 times 7 is 70, and then 5 times 7 is 35, so 70 plus 35 is 105. That's an answer. Down here, I still need to multiply by 7, and still need to multiply by 7. These are still going to cancel, and so here I have x, I have x equals, and then this is the same multiplication here, but it's just minus 105. Okay? Negative 105 right there. Okay? There's another one. The absolute value of negative 9 plus v. And then all that divided by 8. So notice the difference here. The absolute value is just negative 9 plus v right there. Okay, it's just this bit. And then all that's divided by 8, and it equals 3. So in order to isolate this, I have to multiply by 8 and multiply by 8, and so the 8's cancel. Okay, and so I'm going to get the absolute value of negative 9 plus v, and all of that equals 24. So now I have the absolute value by itself. And so I can split into my two cases. The first one is just going to be negative 9 plus v equals 24, which is the same thing without the absolute value signs. And then my second case is going to be the negative version of that, negative 24. Okay. So now I'm just going to add 9 and add 9. And of course, I'm going to do the same steps over here, but I'll end up with a different result because I'm starting with a different equation. So here I have v equals, and that's going to be, what is that going to be? 33. Okay. And here, v is going to equal negative 15. Okay. That's going to do that. I've got two more examples to do. Okay, let's even more. Just two more, so just bear with me here. Okay, 4 times the absolute value of n plus 8, and notice here that really what this is saying is this is 4 times, just like if it had been parentheses. So this is 4 times this whole thing. Imagine this has like parentheses around it, okay? And then all that equals 56. So of course we have to get rid of the 4 because it's not part of the absolute value, okay? And so the 4's are going to cancel. I'm dividing by 4 here, okay? And so then I'm going to have an n plus 8. And all of that is wrapped in absolute value, okay? And then it equals, I should totally know this. 56 divided by 4 is 14. I knew that. 14. Sometimes on these videos I have to cheat because I have like stage fright. So 14, okay? And so now this is isolated, so we can just split it apart. So we'll do case number 1 is just the regular version, and case number 2 is the negative version. So of course I'm just subtracting 8. I'm subtracting 8 over here. So when I balance it, the n equals 6. 6. Right? Yeah, 6. I had a moment there where I couldn't think about 14 minus 8. 14 minus 8 is 6, that's right. And here, negative 14 minus another 8 is going to give us n equals minus 22, I think. Yep, minus 22. So there's minus 22 and 6. Another good example of where they don't have to be the positive and negative of each other, right? Last example problem right here. Same kind of thing as before. Notice that this is saying negative 10 times this whole thing, the absolute value of v plus 2. And all that equals 70. So I've got to isolate the absolute value. Divide by negative 10, divide by negative 10, those cancel, and of course I have v plus 2, and all of that is in absolute value by itself now. And then negative 70 divided by negative 10 is a positive 7. So now I can split, and I'm going to have v plus 2 equals 7, and the negative version over here. Whoops, sorry. So v plus 2 equals 7, which is just the same thing without the absolute value, and then here's the negative version with the negative 7. And so now I'm just going to subtract 2 and subtract 2, and those cancel, of course. I'm left with 7 minus 2 is 5, and negative 9.